All right, in section 3.5, we're going to be analyzing arguments with something called Euler diagrams. That is how it's pronounced, Euler. E-U-L-E-R is Euler, okay? And Euler is a mathematician. He gets credited for this. We use this people's name stuff all the time, like Pythagorean theorem. There's a guy named Pythagoras, right? You know that one probably. Euler was another mathematician. So to start with, valid and invalid arguments, because that's what we're going to be examining. A valid argument, or an argument is valid, I should say, when all premises are true, it forces the conclusion to be true. And an argument is invalid or not valid in the opposite case. So also you'll hear the word fallacy used interchangeably with invalid. So an argument can be an invalid argument or a fallacy, or it's valid. That's the other option. Euler diagrams actually look quite a bit like Venn diagrams, okay? But there's no rectangle on the outside. That's the part that doesn't exist. But they are overlapping or somehow connecting or disconnecting circles. So there's three types of Euler diagram images. Okay, and they're all going to be drawn with circles. So one option is that you have a circle that was supposed to be a circle symbol. One circle and it's embedded inside of another circle. I'm going to tell you what creates these things next. But this is one way that you could have two circles sort of engaging with one another, as one is inside of the other one. Another option, which looks more like our Venn diagrams, is that the circles overlap in a portion of the space. And I need to move that one over for my last one. And then our last option is that we have two I'll have to shift it, non-connecting circles. Okay, so these are our three different diagrams. I think I'll make this one smaller in the middle. That will work. Okay, so these are the three options. Whoops, that was supposed to be a line. So three different categories of options. Each of these has a certain language phrasing that insinuates it's going to become this diagram. Okay, so that's important for us to know. The first picture will happen when we have phrasing that sounds something like this. So this is an example of one. All dogs are animals. So when we see phrasing like this, the two different categories that are described here are dogs and animals. And the category dogs is completely inside of the category animals. So anytime you see the phrasing that has the word all or every, right, the quantifier, that universal quantifier we talked about that's sort of an affirmative and a positive way, you're going to see embedded circles. The second one you're going to see is the existential quantifier. Let's see what my example is I have here. Okay, so in this example, we're going to use the word some. So they'll always say something like some, or at least one, or there exist. This is the existential diagram. So this is something like some people are mothers. So again, there's two categories of people being described, just people in general, right? And then mothers, okay? So when we have something like this, we have people on one side, and we would have mothers on the other. And you might be thinking, well, couldn't you just put mothers inside of the circle for people from a purely logistical sense? The answer is no. And the reason, just from what we know about mothers, is that there are things that are mothers that aren't people, right? Like the dog that had the babies, that's a mother dog. So that would be in that category too. They're not people. They're also mothers. They're just mothers that are outside of our human category, okay? So they have overlapping. So I'm in the middle of this one, right? I'm a people and I'm a mother. Okay. The last category is another universal category. It's the universal category that's the negation kind. So on this one we have something like this. No hamsters or cats. Obviously, right? So two completely different things. And the circles don't overlap. They're not embedded inside of each other. One circle is hamsters, and the other circle is cats. So the ones on the outside are the universal statements. They either are completely inside of one another or they're completely disconnected. The ones in the middle are our existential statements where they have some overlap, but they don't completely encompass one another. So here's the way this works. We get an argument with premises on the top, and then there's a line. That line is sort of like, and the conclusion is what follows. It's like in arithmetic back in first grade, right? You did 4 plus 3, you did a line, and then you said 7 is the answer. Y'all want to, you know what I'm talking about? It's like that. That's the setup. Okay, so the pieces at the top are the pieces that we're told are for sure true. And our question is if it forces what's underneath the line to also hold true. And the way we're going to make that decision is by drawing an Euler diagram. Okay? So our Euler diagram will be based on the statements that start at the beginning. So the first statement actually says, all politicians lie, cheat, and steal. Okay? It doesn't matter whether you believe that's true or not. That's not the point. We're just going to take that statement as if it is truth, and we're going to draw a diagram that represents it. So you see the magic word what? What's the magic word here that tells you how to draw your diagram? All. So what does an all Euler diagram look like? Embedded circles, yes. So this is going to be embedded circles. So we're going to have embedded circles. What's going to be on the inside of the circle? Politicians. Politicians goes in the middle. So I don't have quite enough room to write, and so I'm just going to write poly. Okay, politicians are in the middle. I should put poly, P-U-L-I, I guess, actually. Politicians are in the middle. What is the outside circle then? Lie, cheat, and steal, but it specifically would be like people who do that, right? I mean, so this isn't saying that there aren't people who lie, cheat, and steal that aren't politicians. Like, that's not what it says. It's just saying that the politicians are inside of this bigger category of people, right? So on the outside, these are our people. I'll just abbreviate PPL. Who lie, cheat, and steal. So you can abbreviate it however you wish. When you're looking for these diagrams inside of my math lab, what you're going to probably be seeing is multiple choice options. So just kind of keeping that in mind, this is what you would be looking for. This is the first statement. All politicians lie, cheat, and steal. The second statement says that man lies, cheats, and steals. Now we're talking about an individual person at this point, not a category of something. So what we do is this. We use whatever letter you wish. Again, my math lab is going to give you a letter, doesn't matter. And this X is going to be that man. Now, based on what we're told about that man, where could this X be in my picture?
Inside the smaller circle.
It could be inside the smaller circle. Is that the only place that it could be? Where else could it be? Another color. It could be outside where? Outside the smaller circle, but inside the bigger one, right? So there are two possible locations where the X could be based on the description I've been given. Make sense? Okay, so this is the image that we have. Now we will have to figure out if the conclusion holds true. Is the conclusion that man is a politician a for sure conclusion you can draw based on this diagram? No, you can't. Because the X could be in the outer part. It doesn't have to be inside the inner part, right? So is this argument valid? No, it is not valid. This would be an invalid argument. Whoops. There we go. So this is an invalid argument. On the pieces that were given. Okay, you ready for try another one? Okay, I promise we're going to see some valid ones. We will, but. All right, another one. This one says, some nurses wear blue uniforms. What's the key word that we're looking at here? Some. What does some tell us is going to happen? Overlapping circles, right? Like our Venn diagrams. So we're going to draw circles that overlap. What is going to be each of the categories that these circles represent? Nurses will be one. Blue uniforms, but again, specifically it would be people who wear them, right? So people who wear blue uniforms. Okay, everybody good with that as our first statement? That's the picture. Second statement says D. Boyle is a nurse. So this is a specific person. We're going to use that X kind of notation again. So X is D. Boyle. Where could this X be? Inside the nurse's circle. Did you have in mind over here, Julia? Okay. Where else could it be? Or is that the only place? It could be right here too, right? Okay, so it could be in either one because the nurse's circle encompasses both of those regions of space. All right, so this is the picture for the second description that we're given, the second statement. Our last statement says D. Boyle wears a blue uniform. Does she for sure? She doesn't. So if we knew for sure that she was in this overlap piece only, then we could say yes, right? It would be valid. But we don't know that for sure. It is possible that she's in the outer part of the nurses category, in which case she maybe is one of the nurses that doesn't wear the blue uniforms, right? So is this argument valid or invalid? Invalid. It's invalid. So this is invalid number 2. Okay. All disc jockeys play music. What's our key word? All. What will my circles look like? Embedded circles. What goes in the inside circle? Disc jockeys. We'll call them DJs. What's the outside circle? People who play music. Very good. Now we're starting to get the people in there. This is the people who play music. So you're probably, some of you, in this circle on the outside, right? People who play music. I know my son was this morning. He left with earbuds in his ears, playing something on his phone. I don't know. He's playing music, I think. Okay, so we've got DJs in the middle. People who play music is the outer circle. Flash Phelps is a disc jockey, so that's another specific person. Here is Flash Phelps. Okay, Flash Phelps. Where can I put my X? Right here. Can I put it anywhere else? I can't on this one, right? There's only one location where I can put the X on this one. Okay. Now we're looking at our concluding statement. Our concluding statement says Flash Phelps plays music. This is our first valid argument. Flash Phelps is inside of the larger picture of the playing music part, right? The only way he wouldn't be is if I put the X on the outside of the circle. But I can't put the X on the outside of all the circles, right? I can't put it out here in this argument because the disc jockeys are inside here. So this whole circle is inside of the bigger circle, which means Flash Phelps also plays music. So this one is a valid argument. Okay, I'm going to do one more. I know this is not number 4. I'm going to sort of take a step back. So just draw it on the back of your piece of paper or something like that. So I do not have an example that starts out with the negation one that said no, and I want you to have one. So I'm going to just create that sort of in the midst of what I'm doing right now. We're going to put it at the end of my slides, but just put it wherever you want to put it with yours. And this is the argument we're going to go with. So my first statement is going to be no dogs or cats. I'm going to do it that way. I think I wrote one down. I actually am making this up as I go. No, I didn't. Okay. What do I want to say next? All right, I've got one. Deke is a cat. Therefore, let's spell Deke the same way both times. Deke is not a dog. We'll go with that. Sure, that'll work. Okay, what's our key word in our first statement? No. What does that tell you about my picture?
Two separate circles.
Two separate circles. And what are these circles representing?
Dogs and cats.
Yep, dogs is one, cats is the other. Okay, what's next?
Make your X. Or identify what the X is.
Yeah, we're going to give Deke, which is the name of the person, creature, whatever we have in here, right? In this case, it's a cat. The letter X. So we're going to identify him by the letter X. X is Deke, or Deke is X, either way, whatever. So where will the X be? In the cat circle. Okay, so this is the second description. Deke is a cat. All right, so the question then, or the conclusion then says Deke is not a dog. That's valid. Yeah, this would be a valid argument. Now, notice if the description just says Deke is not a dog, or if I switched these two, like if the statements themselves had been switched to start with, these two switched, I wouldn't be able to make the same drawing conclusion, okay? So if this had said Deke is not a dog, then Deke could be here in the X category where the cat is, but Deke also could be out here, right? Deke could be my hamster or my son, right, or whatever, right? Like it could be anything, right? So the order of it matters. It's really important that you're paying attention to the order that the argument is structured in. All right, let's go back then to number 4. Number 4 actually starts out as a picture form, and you're asked to create a statement, an argument based on the picture. Okay, you're going to have some of these inside of my math lab as well. So we have a picture that says pet lovers and cat lovers, and there's an X in it, and on the side it says X represents Jessica Long. So let's start with these circles. Because of the way the circles are constructed, what kind of a statement will this start out as? All. Good. All what? Good. We start with what's inside. So all cat lovers are pet lovers. All right, that's the first statement. The next statement has to do with the X and where it's located. So the X represents who? Jessica Long. So my second statement is going to start out with the Jessica Long. What about Jessica do we know?
She loves cats.
Yeah, Jessica Long loves cats. Or you could say is a cat lover, if you will. She loves cats. All right, so what conclusion would we draw from there that makes this a valid argument? Yes, Jessica Long is a pet lover or loves pets, if you wish. Okay, so it's doing exactly what we did on the other problems, just reversed. Okay, any questions on that? Okay, I think there's one left, right? This one's the most complicated. Any idea why I say that? I know it is because I've done it before, but can you tell why it should be more complicated based on what we've already done in this lesson? There's more statements before I have my conclusion line, right? There's more going on. There's 3 statements before the line. So that's going to make it more complicated just by default. So we're going to start with the statement at the beginning. It says, all people who drive contribute to air pollution. Okay. So, and I need more space that was supposed to be used for this. So let's actually cut that. We'll put it over here. So it's there, but over here. Okay. So what's my keyword I'm looking at? All. What does that tell me is going to happen? Embedded circles. So I'm going to draw embedded circles over here. What is my inside circle going to be? People who drive. And just for the sake of abbreviating, I'm just going to write drivers. Because no cats are driving, so I think we're okay with that, right? People who drive are drivers, okay? What's the outside circle going to be? Yeah, people who contribute to air pollution. That's my outer circle. So people contributing to air pollution. And I'm abbreviating a little bit along the way. Okay, that's my first statement, excuse me. What about my second statement? Yeah, so we see another statement that should be embedded circles. That word all tells us that, right? Yeah, and so it needs to have an embedded circle, but we have to be careful how we embed it. This embedding has to start with the people who contribute to air pollution being the inside circle of something else. So the people who contribute to air pollution right now is my outside circle, and it needs to be inside of something else, so I'm going to draw another circle around it. So the way this one's set up, I need 3 embedded circles. Now, I already have the 2 that are inside labeled. What is going to be the outside circle's description? People who make life a little worse. You know people like that. And they may not necessarily be the people who contribute to air pollution, right? Maybe not. People who make life a little worse. I don't know how to abbreviate that much better than just to write it out. So I'm just writing all that on that one. Okay. Those are my first 2 statements. My next statement says, some people who live in a suburb make life a little worse. Now, this is a little bit different. In all the other cases, we actually had a specific person's name, right? Or like a very specific, like said, that man, right? It was a very specific individual. This one sort of seems like a category. But we're going to treat it much the same way because we're not trying to embed or disembed circles. We're trying to figure out where those people, in this case, those some people, are supposed to be with these descriptions. So as we do this, we're still going to make it look like it's specifically x equals. So x is going to be some people. And we need to figure out where in the world those some people can be based on that third line. It says, some people who live in a suburb make life a little worse. So where could those some people, these are our suburb people. Why am I not you? That's right. Suburb people. Where would they be? Or where could they be based on the description? Okay, here? Okay, what did you have in mind?
Like the Venn diagram.
Okay, so we're going to draw them with an X. We're not going to draw them with circles. I think that might be what you were thinking. Okay, so where could they be? It says they make life a little worse. They could be here, right? They could be here. Could they be here? Do those people make life a little worse? Okay. Could they be here? Okay, those people make life a little worse. Could they be out here? No, that's the only place they can't be in my picture. I mean, those are the 4 options. And they can't be in my 4th one because the people that are outside of the circle would not be the people who make life a little worse. So these are my 3 places that they could be. All right? So the last conclusion statement that we're trying to decide if it's valid or not says, some people who live in a suburb, that's my X, drive. Maybe. Do they have to? No. I had 3 locations that those X's could reside in, and they're all possibilities based on what I've described, right? They don't have to be in any one of those 3 places. They have to be somewhere, right? One of those X's has to work, but I don't know which one of it is. So I can't guarantee that the X actually will be inside of the little circle in the middle all the time. It's just an option. It's an option that the X could be inside of the middle circle. There's no guarantees that it's there. So that makes this an invalid argument because of that. I don't know where that circle or where that X is going to be. I can't guarantee it's inside of the drivers. Okay, I think that's the most difficult one because it's the weirdest, as well as having the most pieces.